video, and we're going to start with section 1.5, and we're going to need our trig unit circles. So you should have your unit circle out here, just an example one, but you have one on the back side. And your trig chart will also come in handy. We're actually going to see what that chart would look like if we did it onto a graph for the first two columns, the sine and the cosine. So that's our goal today, is to kind of see what the chart would look like if you graphed it. So we're going to just start with one of the easiest ones, and it's y equals the sine of x. So there's two things we need to write down first. We need to write down A, and that's going to stand for amplitude. So write that at the top of your paper, amplitude. And what that is that's the height of my graph. That's how high up and how low down that graph is going to go. It's the height of the graph. And what we do to find it is we find the coefficient of the trig function. We look at the coefficient of the trig function and we find the absolute value of that. So it's really going to be the absolute value of A. Now if I was to write this in standard form, it would be y equals A times the sine of B times x. Because there might be a number in front of the sine of the trig function, and there might be a number in front of the x. In this case, they're both ones, because there's like a 1 in front of the sine and there's like a 1 in front of the x. But there may be other numbers in front. Like you see over here, there's a 2 in front. So this is our standard form right here. This is a b, bx. Now the A is our amplitude, the P stands for period. Now, a period stands for one rotation. That's a period, one time around our unit circle. So it stands for a rotation. To find our period, we need to take our normal rotation, 2 pi. So that normally would be one time around my circle, would be 2 pi. 180 is pi. So second time around, or the other half, would be 2 pi. And we're going to divide it by whatever's in front of our x number, b. So it's 2 pi divided by b. That's my period. If we know these two items, if we know what A equals and what P equals, then they're really easy to graph. And I'll show you how that works, and I'll show you using the chart as well. So here's how it works. My A is telling me the height. So if I look at this first graph, what is my amplitude? What is the absolute value of the number that's in front of my trig function? It's going to be the absolute value of 1, which does equal 1. That means the highest my graph is going to go is a 1, and the lowest it's going to go is a negative 1. That's what that means. That's what this amplitude's telling me. So I'm going to count this, each one as a half. Actually, let's make each one be a fourth. So this would be 1/2, and this would be 1. This would be negative 1/2, and this would be negative 1. That way our graph's not too crunched up. We'll spread it out a little bit. Now, if you remember before, I talked about the sine and the cosine having to be between 0 and 1. Because remember, sine, SOH, the hypotenuse is on the bottom. That means the bigger number is always on the bottom, which means it's going to be a fraction less than 1 or equal to 1. So we already knew that the sine curve has to be somewhere between these two. Can't be bigger than 1, because your higher number is never going to be on top of your sine fraction. So that would be what the A is telling me. Now, what's my period in this graph? It's 2 pi divided by whatever's in front of x. What number's in front of x here? It's just a 1. So it's 2 pi divided by 1, which is 2 pi. So my period is 2 pi. My amplitude is telling me I'm going to go up 1 and down 1. My period is telling me that I'm doing one rotation around the circle, which is 2 pi. So what I'm going to number on here is we'll go over one line and put a pi, and then we'll put a 2 pi, and then we'll put a 3 pi, and then I'll make one more line and make a 4 pi. How many rotations did I just show on my graph? Two rotations. One rotation would be 2 pi. Another rotation would be over to 4 pi. So I actually went around my circle twice. Now here's where you need your chart. So you don't have to have it, but it makes it a little bit easier to understand if you have your chart out. So on the back side of your unit circle, look at your chart. And I'll show it to you on the unit circle, but it's easier to see on your chart. If you look at the sine column, okay, now look at this point right here at 0 degrees. You look up here for a second, keep your chart on your desk. Do you remember which one was the sine and which one was the cosine? Was the sine x or was the cosine x or was the sine y or was the cosine y?
Sine was y.
Sine was y. So what is my sine of this angle right here? 0. Now look on your chart. At 0 degrees, does it say sine equals 0? Yes. So we know that that's one point on my graph, is that at 0 radians, it's going to be 0 is going to be my answer. So my graph here at 0, if I put a 0 in here, the sine of 0 equals 0. So that's going to be 1 point on my graph. Now let's look at pi. Go down your chart, halfway down to the 180 degrees, and look at pi. What is the sine of pi? 0 again. So that means that I'm going to put another 0 right there. Now go all the way to the bottom of your chart. 2 pi. What is the sine at 2 pi?
0.
0 again. These are all called intercepts. That's where they intercept the x-axis. What do you think my next intercept, if I go around the circle again, is going to be? At 3 pi and 4 pi. You're going to have another intercept here. You're going to have another intercept here. All those are going to have a sine value of 0. They're all coterminal angles for each other, so the 0 and the 2 pi are coterminal, but they're going to have the same value. 2 pi and 4 pi are coterminal. They're going to have the same value. Pi and 3 pi would have the same value. They're all going to have 0. They're all going to be intercepts. Now let's look on your chart, and let's go to pi over 2, half of a pi. So you're at 90 degrees. Half of a pi. If I show you here on the unit circle, here's 90 degrees, right up here. What is my sine value? 1. Now, if you look down the chart, is that the largest value you see on that chart?
Yes.
For the sine? Yes. Sine doesn't become more than 1. So when I go to here at pi over 2, I'm going to go up to my maximum value of 1. That's called a maximum. That's a max value. So maximum will be a 1. Now, if I went to pi and it was 0, what if I went to 3 pi over 2, which is 270? If I went to 3 pi over 2 on my unit circle, way down here at the bottom, what is my y value or my sine value? -1. That's going to be the lowest value we get. That's called a minimum value. So at this 3 pi over 2, I'm going to go down to -1. Now I'm going to draw that curve in, and then I'll get out of the way so you guys can see it. That's what that curve is going to look like. What that shows us is that as we go down the charts, or as we go around the unit circle, this is what the sine does. It first goes up to a maximum value. Then it comes back down to 0. Then it comes down to a minimum value. Then it goes back up to 0. Let me show you that on the unit circle. Here's my starting point. What was my sine right here? 0. As I go up, the sine gets to a half. Then the sine gets to radical 2 over 2, which is 0.7. So this is 0.5, that's 0.7, it's getting bigger. This is 0.86, getting even bigger. And then it gets all the way up to 1. But we know sine can't go higher than 1. So what happens as we go around the circle? It starts to go down again. Here's 0.86 again, here's 0.7 again, here's 0.5 again, and then it's back to 0. So it goes up to 1, and then it comes back down to 0. I'm just looking at the y values. That's exactly what this did. It went up to 1, and then it came back down to 0. Now, as you kept going, it went down to -0.5, or -0.5. Down to -0.7, down to -0.86, all the way down to -1. And then it went back up to -0.6, up to -0.7, up to -0.5, and then back up to 0. So that's exactly what this showed us. It went back all the way down to -1, back up to 0. Now what would happen if I went around the circle again? You get the same exact same wave or curve. Now here's how I remember sine curves. A sine curve will always look like a bow tie. Do you see the bow tie?
Oh, yes.
Keep looking for it. Here's the two sides of the tie. If you straighten it, it'll be a nice bow tie. Okay, that's how you know what if it's a sine curve or not. It has to look like a bow tie. It doesn't look like a bow tie, it's not the sine. Here's one part of the bow tie, here's the other part, here's the dot or the knot in the middle. Okay, so it has to look like a bow tie. If you were to continue your graph and make two rotations, I'd make another maximum. These down here are called minimum values, and I would make a second curve, a second wave. These are my minimum values. So that would be your sine curve, just the sine of x. That's basically a picture of what's on your chart. If you went down, straight down your chart, straight down this first column right here, straight down the column, you would do that curve. It would go at 0, it would go up to 1, it would go back down to 0, it would go back up down to -1 and back up to 0. That's exactly the curve that you would see if you went down your chart. This is just a picture of what's on your chart. It's a picture of what you do when you go around the circle. Bless you. Now let's look at the second one because it's a slight bit different. There's a 2 in here now. So what's my amplitude going to be here? It's the absolute value of whatever's in front of my trig function, which is now a 2. So there's 2. What is my period? It's 2 pi divided by whatever's in front of x. What's in front of x? 1. So it's going to be a 2 pi period. Okay, so with those two values, I can now set up my graph. I know that I'm going to go up to 2 and down to -2 because that was my amplitude. That tells me how high and how low to go. Well, Mr. Weberly, I thought sine could only be 1 or -1. Well, what happens if it comes out of 1 and you double it? Then it's a 2. The only reason it's going to 2 is because you're doubling whatever the sine value is. So you're taking this value and you're doubling it. So yeah, now the highest could be is 2, because normally a 1, and if you double it, you get a 2. Or the lowest it could be is a -2. Period is still 2 pi. So I'm going to do a pi here, and a 2 pi, and a 3 pi, and I'll make one more line here and do a 4 pi. Again, that'll be 2 rotations. They usually like you to do 2 rotations. You don't have to, but do 1 rotation shows it, but 2 rotations kind of shows that you could go around the circle. You could go around the circle as many times as you want to. You can make the wave as long as you want to make the wave because it continues to do the same thing as you go around the circle. So my amplitude is 2. Now this is a sine graph. Where does the sine graph have to start? At 0, because your very first point on the sine on your chart is a 0. So you're always going to start here at your sine curve, unless we're shifting it up or down or sideways. Otherwise, you're always going to start at 0. Now my 3 intercepts. Remember we had 1, 2, 3 intercepts with 1 rotation. I added the last 2 intercepts. Are going to be at the same places. These are going to be my intercepts. Halfway between the first 2 intercepts is going to be a maximum value. Halfway between the next 2 intercepts is going to be a minimum value. Okay, we can see that when you look at your chart. I'll show you on the unit circle. Here's my 1 intercept. Here's my other intercept. halfway between those is my maximum value. It's the same thing on your chart. Halfway between 0 and pi is your pi over 2, which is your maximum value. So all you have to do is find your two intercepts. Halfway between them, go to a maximum. Halfway between the second two intercepts, go to a minimum. What am I going to put halfway between 2 pi and 3 pi? Another maximum. It's going to be up here. Halfway between 3 pi and 4 pi? A second minimum. And then you're just going to draw in your sine curve. That's two rotations. That's two bow ties right there. Look at it. Make sure you can see the bow tie. Now I stretched that graph a little bit. Did you see how this graph got stretched up to 2 and down to -2 because of that 2? That was a vertical stretch. Okay, we stretched it out a little bit, made it a little higher and a little lower because there's a 2 in front. We doubled all of our values. We took all the values on the chart and we doubled them. So it stretched it up to 2 and it stretched it down to -2. So that's how you stretch a graph, is just put a number in front of the trig function. You'll stretch it up or down. Question? Okay, as you go around your unit circle, it goes to the top value and then it goes back to 0. After that 0, it goes to the bottom value, then it goes back up to 0. As you look at your unit circle, just follow the numbers around your unit circle, all the y values, and you'll see it. All right, moving on. We're going to see a cosine curve next. But the same applies for the A and the P. What is my amplitude of this graph right here? It's going to be a half. Absolute value of a half equals a half. That means that we shrunk it a little bit. We didn't do 1 and -1. We shrunk it down a little this time. So rather than make my graph really small, I'm just going to put, I'll put a half up here. And I'll put -1/2 down here, just so it's not as tiny. Just keep in mind that we actually shrunk it a little bit because normally it would be 1 and -1. So we shrunk it to a half and -1/2. Now the period is 2 pi divided by whatever's in front of x. What number's in front of x here? 1. So it's still going to have a 2 pi. So that means I could still do a pi here, a 2 pi, a 3 pi, and a 4 pi. Starting on our next graph, that's going to change because we have a number in front of x on the next graph. But for these three, this would be our x-axis, would be our radians. X-axis is going to be our radians. Now let's draw in our intercepts, but this time it's a cosine graph. So back to the unit circle for a second. At 0, what is my cosine value? 1. So the cosine actually starts at a maximum. Because nowhere on the chart is there a number bigger than 1 on the cosine column, right? So that's actually a maximum value. It starts at the top. So if you look at your graph, you're going to start at your maximum value. Your cosine right away is a maximum. And it's going to also end at a maximum. So a 2 pi is going to be another maximum. Those are two coterminal angles. 0 and 2 pi are the same angle. They're both going to be maximums. Guess what halfway between these two is going to be? And let's look at it. On here. Here is my 0, right? Or my maximum. All the way around would be my maximum again. Halfway between it would be right here. What was my cosine? My x number? -1, which on my graph represents a minimum value. So halfway between these two is going to be a minimum. So it's going to be down at the -1/2. Guess what halfway between the maximum and the minimum has to be? An intercept. Halfway between a maximum value and a minimum value is going to be an intercept. You could see that directly on your chart. Let me show you here. You look down the cosine column. Here is a 1, and here's a -1. Halfway between those two is a 0. It's an intercept. So halfway between a maximum and a minimum is always going to be a 0. So halfway between those two would also be a 0. There is your cosine curve. Now what does that look like? We always like to name these so it's easy to remember. I call it a V shape. Yeah, I call the cosine curve a V-shaped curve. Sine curve I call a bow tie. Cosine I call a V. Now I call that a V because it starts at the top and it ends at the top. And it goes down in the middle, so it's a V-shaped curve. My maximum is 1, but what did we do to that number 1? What did we multiply it by? So if I put a 0 in here, cosine of 0 is 1. But what's 1 times a half? 1/2. That's why I put the 1/2 there. Because what this 1/2 does is it shrinks my graph from 1 down to a half. So this is called you're shrinking. You're shrinking it down. It's a shrink graph because you multiplied everything by half. You took all the values on your chart and you cut them all in half. They made them all smaller. Now, if I did another curve, I would go back down to my, let's see, I'd have my intercepts here. I'd have another minimum down here, another maximum up here, and I'd have another V-shaped curve. That's my 2 V-shaped curves, 2 rotations. Cosine always looks like a V shape. There's a V, there's another V. The sine curve always looks like the bow tie because it starts at 0. Let's look at the next graph. Let's find the A and the P. Okay, what is my amplitude of this graph? It's the absolute value of -1, which is 1. So that means that I'm going to go up to 1. Let's do that as a half, and that is 1. -1/2, -1. So it's going to go up to 1 and down to -1. That's going to be the amplitude of my graph. Now the period is 2 pi divided by whatever's in front of x. If I put a 1 here, what number, or what do you see in front of x? It's 1/2 x. X over 2 means you could take the x over here and do 1/2 x. So this is a 1/2. How do I divide by a half? You could change that to 0.5 and do it in your calculator, or you could multiply by the reciprocal. So I could take 2 pi and multiply it by 2 over 1. What's my actual period going to be in this graph? 4 pi. That means I need to use 4 pi just to get 1 full rotation. So what I'm going to put here is, I'll use this. I could use the same ones, or I could number them all shorter ones. I'll still do pi, 2 pi, 3 pi, 4 pi. That's going to be 1 rotation, even though it looks like 2. Because you're cutting everything in half, so it's going to take you 2 times around to get to the 2 pi. If I took 4 pi, think about this right here. If I took 4 pi and put it right here, what is 4 pi divided by 2? That's 1 rotation. That's why it takes me to 4 pi to get to 1 time around my circle. All right, now what graph am I looking at? The sine. Now this negative right here, I don't want it to throw me off. So what I need to do is plug in a 0 to see what's going to happen here. So I'm going to put a 0 right here. What is 0 divided by 2? 0. What's the sine of 0? On your chart, sine of 0 is 0. And what's 0 times -1? Still 0. So 0 is my first point. Sine curve, it always is 0. Now let's plug in a pi though. I think pi we already know is going to be a 0 also, right? Isn't the sine of pi also 0?
Yeah.
So sine of pi. Oh wait, hold on a second though. If I put in a pi right here, it's not sine of pi. It's the sine of pi over 2. So look at your chart and tell me what pi over 2 is. Yeah, pi over 2 is 1 right here. 90 degrees, the sinus value is 1. So let's look at that. Now, if the sine is 1, and then I multiply it by negative 1, it's going to be a negative 1. 1 times negative 1 would be negative 1. So if I put in a pi, I'm going to get a negative 1 to come out. If I put in a 2 pi, I'm going to get my intercept. Because 2 pi divided by 2 would just be pi, and the sine of pi is 0. That means 4 pi is also an intercept. What do you think is going to happen if I plug in a 3 pi? Okay, 3 pi over 2. Look at your chart. What's the sine at 3 pi over 2? 270. Negative 1 times negative 1 out front is positive 1. So that's going to go up to my maximum. So my curve is going to look like this. The bow tie curve. You see the bow tie there? Now, what changed on this graph besides the period became a 4 pi? What actually changed also?
It went down.
Yeah, the negative, see this negative right here? It made it go down first. Look back at our first graphs. What did we do? First we went up. Sine always goes up first. As you go around the circle, it's going to go up. But if you put a negative in front, it's going to make it go down first. So that's a negative curve. It made it go down. All right. Got that one?
Yeah.
Good to move? All right, let's look at the next one. 2 cosine of 2x. I actually should have put y equals 2 cosine of 2x. So let's find the a and the p. What's my amplitude of that graph? 2, it's the absolute value of 2, which is 2, because that's the a right here. This is my a, this is my b. Period is 2 pi divided by b, which is 2 pi divided by 2, which is just pi. So in this case, 1 period is just going to be pi radians. So what I'm going to do then is, let's see, let's make this pi over 2 here. Let's make this pi. We'll make that 3 pi over 2, and then we'll make that 2 pi. So that'll be 2 rotations. Now, what kind of curve is it going to be? Is it going to be a bow tie or a V? It is a V because it's cosine. Cosines are always V's. So cosine starts at our maximum. Starts at max. So that means that my maximum is going to be 2, right? 1, 2. So my maximum is right there. My minimum would be a negative 1, negative 2. Now, it's going to start at a maximum, and my period is pi. It's going to end at a maximum. What's going to happen halfway between my two maximums? Halfway between there would be pi over 2. What's that going to happen? Is it going to be an intercept or is it going to be a minimum? Halfway between. Remember a V shape? It's got to be a minimum. Halfway between's got to be a minimum. What happens halfway between every maximum and minimum?
Intercept.
You get an intercept. So those are going to be 2 intercepts right there. And then I can do my second rotation. I'm going to have an intercept. I'm going to have another minimum. I have another intercept, and then I'm going to have another maximum. It's always going to start and stop at a maximum. That's the cosine curve. It's going to be 2 V-shaped curves. That would be your cosine of 2 cosine of 2x. We stretched it up 2. So you stretched it up 2 and you stretched it down 2. And you had your intercepts. And your period, 1 period was pi this time because you're doubling everything. Normally it'd be a 2 pi, but since you're doubling everything, 1 period is just pi. So that would be 2 cosine of 2x. And I move to which is going to be the last one for today.
Yeah.
Good to go? Yep. Okay. Okay, so the last one will be a half sine x minus pi over 3. All right, so we need to find the a and the p. So let's look for my amplitude and my period. what is going to be the amplitude for this graph? It's going to be absolute value of 1/2, which is a half. So automatically, I go to my chart here, and on my y-axis, I'm going to go up a half and down a half. So I don't want to start here. I might put it here, or I might go up higher or whatever. So we could go a half right there just to show that it did get shrunk a little. So there's a half and negative a half. If we went up here, that'd be 1, that'd be negative 1. But we're not going to go that high, because we're basically shrinking the graph and we're cutting every value in half. We're finding the value of this, and then we're cutting it in half. We're making our graph shrink a little, make it smaller. Now, what's the period here? 2 pi divided by whatever b is. What number is in front of x? 1 is. I don't care about this right now. We're just going to look in front of x. In front of x, there's a 1. So it's still going to have a period of 2 pi. So that means, okay, I'm not going to write those in yet, but we do know that we're going to have, normally it would be a 2 pi period. Let me extend this out a little bit. Now the reason I don't want to write them in yet is simply because I see this right here. And I know that's going to do something to my graph. It's actually going to shift it. It's going to shift it. So we got to see which way it's shifting it, because it's got a minus pi over 3. Now where would I normally start my sine graph at? 0, because that's the bow tie. So I'm going to see what would happen to this pi over 3 if I had started at 0. Okay, so I want to see what could I put in for this x to make it equal 0 where I would normally start. Okay, so if I added pi over 3 to both sides, that means that x has to be pi over 3. Just think about it for a second. If I put a pi over 3 right here, what's pi over 3 minus pi over 3? 0, and the sign of 0 would be our 0, right? So this right here would be my intercept. It would make my 0. So instead of starting here at 0, I'm going to put pi over 3 right here. That's going to be my 0 point. That's going to be my first intercept. Now in red, I'm going to put what we would normally do. If this didn't have a minus pi over 3, if it just said x, we would have started right here. But since it had this negative pi over 3 and we had to solve it, it's telling me now I have to start at pi over 3, not at 0 anymore. So basically I've taken my starting point, I'm shifting it over a little bit. Now we normally end our first rotation at 2 pi. So we need to find out what could I put in to this x that would make it equal 2 pi so I could see where now I'm going to stop. Normally I would stop at 2 pi. But it's telling me I got to shift it a little bit. So I got to solve this to find out where I'm going to end. So add pi over 3 to both sides. Those cancel out. And what's 2 pi plus pi over 3? Let's change 2 pi to have a common denominator. Let's make it become 6 pi over 3. Is that the same as 2 pi?
Yeah.
So what is 6 pi over 3 plus 1 pi over 3? 7 pi over 3. So let me see. This would be 1 pi over 3 on my graph. 2 pi over 3 will be the next line. This will be 3 pi over 3, which is pi. 4 pi over 3, 5 pi over 3, 6 pi over 3, which is 2 pi. This will be 7 pi over 3. That's going to be where I end my graph. Where would I normally end my graph? What's my normal one rotation? 2 pi. So this is where I would have normally ended the graph, right there. So now I'm going to end it right there. So you can see the red one got shifted over to the black one because we're shifting this negative pi or positive pi over 3 units. When we added the pi over 3 to both sides, it became a positive pi over 3 shift. We're moving it pi over 3 units. Now let me finish what we got here. On a sine curve, what does it look like? A bow tie, which means halfway between these two has to be another intercept. So this is 1 pi over 3, 2 pi over 3, 3 pi over 3. 4 pi over 3 is going to be halfway between those two. It's got to be another intercept. Halfway between my two ending points is another intercept because I have to make a bow tie graph. Now, halfway between the two intercepts is not going to be either one of these 2 points because they're 1/3. This is 1/3, and that's a 1/3, and that's another third. So we're going to go right between those two, and we're going to go up to a maximum, which in this case is actually a half. So halfway between those two is up to a half. You've got to split your intercepts halfway to get to your maximum value. And you're going to split your intercepts this way to get your minimum value of negative a half. So it's going to be right before the 2 pi. Between those two lines is going to be your minimum. So your sine curve is going to look like this. If I had not had this shift right here, if I did not have a negative pi over 3 next to it, my halfway point would have been pi. This would have been up to here. This would have been down to here. And this would have been my curve. So can you see what this pi over 3 did to my curve? Normally it would have been this red one, but it moved it over because it had the pi over 3 there. And it moved it over a positive amount because it took a positive pi over 3 to make it equal 0. So it moved it over a positive amount. So if you see a minus in here, you're going to be moving it over a positive amount. What if I see a plus in here? You're going to be moving in a negative amount, this direction over here. So in this, you just got to find out what would make it equal 0 and what would make it equal 2 pi. Those would be your normal starting and ending of a rotation. So that's called a horizontal shift. Horizontal shift happens when you're adding something to the x. Now tomorrow we'll look at a vertical shift, which happens when you add something to the trig function. That's when it'll be a vertical shift. But back here it'll be called, what we call it, a horizontal shift. That was 1.5 part 1. And then we'll have